Good morning, students. Today we'll discuss VSAQs. Up to now, two streams over. One is the long answer question. Total 6 LAQs. I finished 6 LAQs. Out of 6, you are reading any 4 plus 1. Next, SAQ, short answer question, including problems. 30 SAQs with 3 problems. 30 SAQs with 3 4 marks problems. Over. Long answer questions 6. Short answers 30 plus 3 problems. Remaining, we are going towards VSAQ zone. Very short answer question. Now, here, very short answer questions, 10 VSAQs you are getting from 14 lessons. In 14 lessons, few lessons, 4 marks weightage. Few lessons, 8 marks weightage. Few lessons, only VSAQ weightage. In that one, first lesson, kinetic theory. According to our lessons order, this is the 14th lesson. From kinetic theory of gas. From kinetic theory of gas, we can get 2 VSAQs. 2 plus 2. 4 marks you are getting from kinetic theory of gas. 2 VSAQs from kinetic theory. Thermal properties of matter. Total heat lesson divided into 3 parts. Thermal properties of matter, first lesson. Thermodynamics, second lesson. Kinetic theory of gas, third lesson. Heat, total 3 parts. From that 3 parts, kinetic theory of gas, 2 VSAQs. Thermal properties of matter, 2 VSAQs. 2 VSAQ. 2 VSAQ. And one more lesson, mechanical properties of fluids. Mechanical properties of fluids. From this mechanical properties of fluids, you can get 2 VSAQs, 2 plus 2, 4 marks. This is the marks. How many VSAQs? 2 VSAQs. Total 6 VSAQs coming from 3 lessons. From 3 lessons, you can get 6 VSAQs. Remaining 4 VSAQs. Now, here, physical world. Physical world, 1 VSAQ. Next, motion in a plane. 1 VSAQ. Units and measurement, 1 VSAQ. Units and measurements, dimensional formulas, 1 VSAQ. Now, last one is there, student. Total 10 out of 10, 6 VSAQs from 3 lessons, 4 VSAQs from 4 individual lessons. One is physical world, 1 VSAQ. Motion in a plane, 1 VSAQ. And units and measurement by rotational motion. Here only write. Because sometimes we are getting 1 VSAQ from rotation motion. Sometimes you can get VSAQ from units and measurement. That's why from these two, any 1 VSAQ. And last VSAQs from laws of motion. Laws of motion 1. Total 6 plus 4. 6, 1, 2, 3, 4. So this is the VSAQ zone from intermediate first year. Total 10 VSAQs from 7 lessons. 50% of lesson you are reading in that one selected VSAQ student. 2 VSAQs means kinetic theory of gas, weightage 4 marks. Don't think weightage 4 marks means SAQ, 2 plus 2. Thermal properties of matter, 2 plus 2. Mechanical properties of matter, mechanical properties of fluids. In that one more zone is there. Mechanical properties of solids. That is the pure SAQ. This 3, this 4. Here, units. Last annual examination, they gave question from units and measurement. Before that one, question from rotation motion. Units, one VSAQ coming means rotation motion, direct 2 4 marks questions. Otherwise, rotation motion, VSAQ 1 coming means 1 4 marks question, 2 VSAQs. Units, otherwise rotation motion. Compulsory loss of motion, 1 VSAQ. This is the analysis of VSAQ student. Now today we are going towards kinetic theory of gas. Total 2 VSAQs. Every VSAQ, remember, every VSAQ, maximum length of VSAQ answer 2 lines, minimum 2 to 3 lines enough. Because few questions, center of mass, center of gravity, you take from rotation motion. Center of mass, center of gravity. That question they are giving in 4 marks. Sometimes you can get that question for VSAQ also. Way of writing in VSAQ, way of writing in SAQ, both are different. That's why special concentrate on VSAQ. Our lesson, first lesson, kinetic theory of gas. From this one, 4 marks coming, 2 VSAQs. Here, first of all, kinetic theory of gas. This is the 14th lesson from first year, pure VSAQ weightage. And now listen. Don't read 4 marks question from kinetic theory of gas because this lesson weightage only 4 marks, 2 plus 2. Define mean free path. Question number 1. How many questions you are reading means here? 1, 4, 5, 6. 1. Question number 1. What is the question number 1? Define mean free path. You know, action reaction. For example, this is the one container like this. See, average distance traveled by a molecule in 2 successive collision. Why we are taking the 2 successive collision means one is the action mode, second one obviously reaction mode. This one you are writing. Define mean free path means definition 1 mark with formula 1 mark. Average distance, shortcut. Average distance traveled by a molecule in 2 successive collisions. For this statement 1, this question most important 3 star and formula. This is the formula from kinetic theory of gas. Derivation also there in 4 marks. In that one, what is the L, what is the N, what is the D? L nothing but obviously mean free path. N nothing but number density. Meaning in the given volume, how many molecules present? Number of molecules present in the given container. Number of molecules present per given volume. D, diameter of molecule. You are writing only 2 points definition of mean free path. Average distance traveled by a molecule in two successive collision. This one formula, student, under root pi and d square. Next important question: when does real gas behaves like an ideal gas? When real gas acting as an ideal gas, you know very well, ideal gas, where ideal word coming in physics, that is imaginary. Ideal cell, ideal string, ideal gas, ideal black body, all this one imaginary, student. So when does real gas behaves like an ideal gas? So question number 4, according to our order, textbook numbers we are following. When does real gas behaves like an ideal gas? Question I'm writing shortcut. Real gas behaves like ideal gas. Under which condition, student? At very high temperature. At very high temperature, real gas behaves like ideal gas. Ideal gas means imaginary, but one gas we are treating nearly as ideal gas, hydrogen gas. You are writing at high temperature with low pressure. Enough this word. Otherwise, you want out of 3, any 2 point mean, write this one also, low density. At low density, comma, low pressure. Otherwise, low density, comma, high temperature. Select any 2 points. In these conditions, real gas behaves like ideal gas. Next, state Boyle's law and Charles' law. Boyle's law and Charles' law. Boyle's law, comma, Charles' law. State Boyle's law and Charles' law. This one, question number 5. First, Boyle's law. In shortcut, student, listen. Way of writing 2 ways. Any gas laws you take at a time, use 4 terms: pressure, volume, temperature, mass. If you remember, they are saying pressure inversely proportional to volume at constant temperature. That statement wrong. Pressure, volume, temperature, mass. At a time, use 4 different terms. Pressure of the given mass of the gas. Pressure of the given mass of the gas is inversely proportional to volume at constant temperature. This statement you are going means somewhat enlarged statement. That's why you go shortcut. But remember, Boyle's law, Charles' law, Charles' first law, Charles' second law. That Charles' second law in chemistry, word chemistry, you are reading that word, Gay-Lussac law. Any gas laws we are reading, compulsory 4 terms. Thermodynamical variables 4: pressure, volume, temperature, mass. 4 terms compulsory. Now I am giving this statement in short way. What is the Boyle's law means? Pressure is inversely proportional to absolute temperature. In bracket, pressure inversely proportional to volume. See, student, pressure inversely proportional to volume. Here you write in bracket, one is the temperature, one is the mass. At a time you write constant. This one only shortcut. Pressure inversely proportional to volume. P inversely proportional to volume when temperature and mass of the gas remains constant. For this statement, direct 1 mark. Pressure, V, both are inversely proportional. Boyle's law. Then after continuation, Charles' law. Actually, Charles' first law there, Charles' second law there. You write first law. See, volume is directly proportional to absolute temperature. You write here in bracket pressure comma mass constant. V directly proportional to T. One Charles law enough. If you remember, they are going Charles second law also, but here VSAQ means Charles first law with Boyle's law enough. Don't write Charles second law, pressure directly proportional to absolute temperature. Boyle's law, pressure inversely proportional to volume. Two terms constant. I said 4 thermodynamical variables, 1, 2, 3, 4. 2 constant remaining inversely. 2 constant remaining directly. This is Boyle's law and Charles law. Now state Dalton's law of partial pressure. All these questions from chemistry also. Dalton's law, Boyle's law, Charles law, Avogadro law, all this one chemistry side student. Dalton's law of partial pressure. Total pressure, C, and so on, PL. Total pressure exerted, total pressure acted, total pressure acting in the system. Anything, no problem. Total pressure exerted by a gas equals to vector sum of, otherwise sum of individual pressure. Always individual pressure equals to total pressure. Total pressure P total. Total pressure is equals to sum of individual pressures in the gas. This is Dalton's law of partial pressure. Total pressure exerted by a gas is equal to sum of individual pressures. Total pressure always equals to individual pressure. You think VSAQs means how to finish answer in 2 lines. One is mean free path. Average distance traveled by a molecule in 2 successive collisions. At which temperature real gas behaves like ideal gas? High temperature at low pressure. Otherwise, take density also, 2 terms enough. Boyle's law and Charles law, Dalton's law also our student. Next, explain the concept of degrees of freedom. Degree of freedom means very simple word, student. This one, question number 8. What is the degree of freedom means? Very simple. For example, one person standing on road. How many ways that person moving means? Total 4 ways. Either north direction, south, east, west. You didn't say northeast, northwest, that one all sub. Main 4. Like that, gas molecules there in how many possible ways, in how many possible direction, in how many possible types energy transfers in the given system. That is nothing but degree of freedom. Degree of freedom, nothing but total number of independent modes. Number of independent modes to transfer, to possess, to transfer energy in the given system. Just degree of freedom, student. F equals to 3, F equals to 5. This one value, student. This is for monomolecule, single. This is for dimolecule. This is for tri or poly. Degrees of freedom with different possible freedoms in 3 types of molecules. Now, What is the expression between pressure and kinetic? 1 minute, student. All right, next question. What is the expression? Don't think this one derivation part, student, because derivation part long answer. What is the expression between pressure and kinetic energy of gas molecule? In kinetic theory of gas, what is the relation between pressure and kinetic energy? That is the question number 9. You write this one bar. P equals to net. P equals to 2 by 3 E bar. E bar nothing but average kinetic energy. You write terms. P equals to pressure of gas. E bar nothing but average kinetic energy. This term is compulsory, student. Average kinetic energy. Pressure equals to 2 by 3 of E bar. Pressure is equals to 2 by 3 of E by V. E by V only, E bar. This is the relation between pressure and kinetic energy. Last question from kinetic theory of gas. The absolute temperature of gas increased by 3 times. What will be the increase in the RMS velocity? First of all, what is the velocity formula in terms of absolute temperature? Means V directly proportional to root T. This one we are getting from main formula under root of 3R T by M. Now you write V2 by V1 equals to T2 by T1. Now focus on question. Absolute temperature increased by 3 times. T1 they gave T. 3 times. 3 into. If you remember writing by 3, that's why you are getting mistake. V2 question mark, V1 is equals to V. Substitute V2 by V, 3T by T. 2 to cancel. V2 equals to root 3 into V. Our question, what is the increase? Don't think what is the final velocity. What is the increase in RMS velocity? Delta V equals to V2 minus V1. Final value we got root 3V. Initial value V. This one increase, student. V common, root 3 minus 1, you know root 3. 1.732. 1.732 minus 1. 0.732. So we are writing in 2 ways. V2 delta V equals to, direct you write, delta V equals to 0.732 V. Otherwise in percentage into 100 means, student, 73.73 percentage of V. In between these two, anyone, no problem. Again I'm repeating. First question, see student, from this one you can get 100% 2 VSQs, mean free path. Don't enlarge answer. If you remember, they are reading materials means material obviously somewhat big answers. Focus on what is the question, what is the answer. Mean free path definition with formula. If you remember, they are not writing formula, no problem. For this statement, you can get direct 2 marks. Mean free path. Next, real gas. When does real gas behaves like an ideal gas? At high temperature and low pressure. Your marks not related to size. Your marks related to scheme of evolution points. Now, Boyle's law and Charles law, these 2 gas laws famous from physics and chemistry in thermodynamics. Pressure inversely proportional to volume, 2 terms constant. Volume directly proportional to absolute temperature, 2 terms constant. Anywhere gas laws definition coming means focus on 4 thermodynamical variables. Dalton's law, total pressure equals to sum of individual pressures. Next, degree of freedom. In how many ways energy possess, in how many ways energy transfers, that meaning only degree of freedom. total 3 cases we are going degree of freedom definition with individual values. Next, what is the relation in between pressure and kinetic energy in kinetic theory of gas? This one, kinetic theory of gas student, energy of freedom concept we are going. P is equals to 2 by 3 into E bar. This one, long answer from kinetic theory of gas, long derivation part also there. But this question for VSQ. Last one, if temperature increased by 3 times, what is the increase in velocity? We are writing 73% of initial velocity. This total questions from kinetic theory of gas. From this one, you can get 2 VSQs. Now, see student. So, I already said out of 10 VSQs, here, see, everyone focus on these lines. Kinetic theory of gas, 2 VSQs, 2 questions coming, meaning from kinetic theory of gas, 9th and 10th from kinetic theory of gas. Thermal properties of matter, again 2 VSQs. Mechanical properties of fluids, again 2 VSQs. If you are reading these 3 lessons, you can get 6 VSQs. Next, physical world, single question. Motion in a plane, single question. Units and measurement, otherwise rotation motion. From these 2, you can get 1 VSQ. Loss of motion. Just focus on these lessons. Today, I finished kinetic theory of gas. Remaining these lessons, VSQs left. Thermal properties of matter, last time, can a substance contract on heating? 1 question. One more, greenhouse effect, global warming. These 2 questions came from thermal properties of matter. Other than that one, remaining 10 questions there. Thermal properties of matter. Fluids, 2 questions came. Physical world, obviously 1. Motion in a plane, 1. Last time, units and measurement, 1 question came. No VSQ from rotation motion. That's why this time focus on rotation motion, loss of motion. Before this one, say here. Three problems. This is going on. 6 LAQs, minimum 4, maximum 5. Out of 18 LAQs, you are reading 6. In that one, internal choice, you are taking minimum 5. 18, 13. Meaning, in this one, okay, few questions not related to what is that LAQs. That's why in 13 means, for example, you take kinetic theory of gas. What is the ideal gas equation, pressure equation? That question also involved. 5. For this 5, 19, 20, 21. For you want 16 marks from long answer means any 2 section you select. Here I gave 2. Here I gave 2. Here I gave 2. One member reading 19 and 20. Any 1 question you read from 21. One member reading from 20, 21. 2 plus 2, 4. You select 1 question from 19. One member reading 21 and 19. You select 1 question from 20. Minimum 4, maximum 5. Enough? LAQ. Then 30 SAQs I gave. From this one, 24 SAQs you are reading for this upcoming supplementary examination. 3 problems, easy problems only. VSAQs. First you finish 3 lessons for 6 VSAQs. Today I finished kinetic theory of gas. Remain 2 direct questions from thermal properties of matter and mechanical properties of fluids. Okay, we'll continue tomorrow.